Okay, so we're still in related rates. Today we're going to do some just basic stuff, okay? So we've got this situation. We have a circle that has a radius of 8 inches, which is changing. So first we're going to write the formula for its circumference and area. So if you remember, circumference is 2 pi r. Now, the change in circumference. The change in circumference is when you take the derivative of the circumference with respect to time. And you'll get dc over dt equals 2 pi dr over dt. Now that is basically how the radius is changing over time, and dc over dt is how the circumference is changing over time. Now the area equation. Area of a circle is pi r squared. How it's changing over time, the change in area, is dA over dt equals 2 pi r dr over dt. Because we're taking the derivative with r with respect to t, you bring the 2 out in front, so you get 2 pi r and then times dr over dt using implicit or chain rule. Okay, so now we're going to use those two over here in a and b. So they're saying, okay, find the change in circumference and the change in area when its radius is growing at a rate of 3 inches per minute. So in part A, they give us dr over dt is positive 3 inches per minute. So the first part, dc over dt equals 2 pi times dr over dt, which is 3 inches per minute, which means our change in circumference is 6 pi inches per minute. So that's how my circumference is getting bigger. Now, my change in area then, so dA over dt is going to be equal to 2 pi times the radius, which is 8, times the change in radius, which is 3 inches per minute, and this is 8 inches. So 2 times 8 times 3, so that is going to be 2 times 8 is 16, times 3, 48 pi square inches per minute, because you have inches times inches, so square inches. So that is how the area is changing. Now we're going to do the same thing over here, but now my dr over dt is different. Here they're telling me dr over dt, the radius is shrinking at a rate of 1/4 inch per second, which means it's getting smaller. So it's negative 1 inch per second. But again, we're going to find the change in circumference. So dc over dt is equal to 2 pi times negative 1/4 inch per second, which is going to be negative pi over 2 inches per second. So my circumference is getting smaller. And now the same thing with area. dA over dt equals 2 pi, again the radius is 8 inches, times the change in the radius, which is negative 1/4 inches per second. 2 times 8 times negative 1/4, which means it's going to be negative 4 pi square inches per second. Okay, so in this case we have a direct relationship between the two. Okay, but that's what related rates is all about. It's like, how is one changing and causing the other to change? Hence the name related rates, because they are related in some way. Okay, all right. So Superman problem. Okay, so we got Superman. He's in level flight. He's 6 miles above the ground. So here we go. 6 miles up here, and I'm not going to try to draw a man. I'm just going to draw this. That's Superman. Okay, now he's flying level 6 miles above the ground. His flight plan takes him directly over a high school. How fast is he flying when the distance between him and the high school is exactly 10 miles and the distance is increasing at a rate of 40 miles per hour? Okay, so basically he's going along his flight plan, he's going his speed, whatever it is, we got to find. He passes over this high school. Okay, so there's a high school. So I'll put this as a high school. It says the distance between him and the high school is 10 miles. So this right here is 10 miles. And that is increasing at a rate of 40 miles an hour. So this is increasing. This is getting bigger, 40 miles per hour. Okay? How fast is he going? So they basically want to know if he's going this way, how fast is he going? Okay? So this is a triangle trig problem here. So we know this side here is C. Let's say this side is A, and let's say this side is B. Okay? So basically we're dealing with Pythagorean theorem. So the problem or the equation that relates all of my sides, of course, a squared plus b squared equals c squared. And again, we're going to take that, the derivative with respect to t. So you get 2a dA over dt plus 2b dB over dt equals 2c dC over dt. Okay? Well, let's see. They gave us c. We know what c is. C is 10 miles. They also gave us dC over dt. That is 40 miles per hour. Now, they gave me A. A is 6 miles. What's dA over dt? Well, they said that he's flying level height. So dA over dt is not changing. It is 0. Because this height is a constant and the derivative of a constant, the rate of change of a constant, is 0. So basically we know in my equation that this is 0. Now, we need to find b. Well, that's a simple Pythagorean theorem problem. And you can see this is 6, this is 10, this is a 3, 4, 5. So this is 8. Or you could do Pythagorean theorem and find it. Okay? So we know what b is. B is 8. So we know this. We're trying to find that. We know that, and we know that. So now it's just in terms of plugging it in. Okay? So this is 8 times dB over dt equals 10 times 40 miles per hour. So dB over dt equals 10 times 40 over 8 miles per hour, which is 50 miles per hour. So it is very important that you realize when you have a rate like dA over dt, when things are not changing over time, that rate is 0. For instance, we could have said, wait a minute, at the beginning we knew that this right here, a is a constant. If a is a constant height, then when you take the derivative of a constant, you get 0. Okay, so either way, if you can pick out your constants or you know, then you can actually plug in those ahead of time. So anything with a constant, you treat it as a constant. Okay?